All right, as we are continuing through Unit 2-3 notes, we're looking at that 45, 45, 90 triangle, that special right triangle that is going to help us in the unit circle. So as we take a look at this circle here that's been drawn for us, first thing it notes is by making the radius 1, it helps us apply the rules to other situations easier. Yes, it does, for reasons we are going to dive into here. So what we've got for starters is the unit circle. I'm not sure that I like the little dots here. But anyways, what we've got is all around this circle we've marked off where 45 degrees comes in. So what I want to do is add to that, bringing that straight down. All right, now by doing that, first of all, I'm going to imply then that that is a vertical line. The axis is a horizontal line, so we have a right triangle, 45 degrees. And this is where we start applying those rules from that radius of 1. So if the radius is 1, that means that this line right here, the distance from the center out, is 1 unit. What we know then is that this point, this xy coordinate, right? So here's my x distance, here's my y distance. I know that I have gone, in order to get to this point right here, that coordinate is over x up y. Well, to go over x, we're really just simply trying to find the adjacent side of 45 degrees in a right triangle whose radius is 1 or hypotenuse is 1. So we already figured that out up here, right? Here's that 1. My x is square root 2 over 2. My y is square root 2 over 2. So the coordinate is square root of 2 over 2, comma, square root 2 over 2. Now, to go even further into this, to generalize that position, the x itself, let's just draw, hold on, let me change colors. Let me talk for a minute about this triangle. And how would we find x? Like, let's say we are only being told, hey, it's a radius of 1, angle's 45. What is x? So we're going to say, well, we're going to use cosine. So 45 degrees. And that is equal to x over 1, right? So we rearrange the numbers, we multiply by 1, multiply by 1. We find that x is equal to cosine of 45 degrees. Well, when you plug in cosine 45 degrees in your calculator, you get the same decimal approximation as if you were to take square root of 2 divided by 2. Let's do the same thing for y. So to find y, again, all we're going to be given is the hypotenuse or the radius of the circle 1 in angle 45. So here we have the opposite over hypotenuse. But again, that's y over 1, so you multiply by 1, multiply by 1. And again, y is equal to sine of 45 degrees. So can we approximate, can we generalize that, right? If we assume always that our radius is 1, because that's why we call it the unit circle, as it is 1 unit in radius, that's where the name comes from. So if we know that we're going to keep that hypotenuse 1, and we're going to find these different angles, we're going to generalize this and find out that the xy coordinate is always going to be cosine of our angle, comma, sine of our angle. And that is really, if I go even further up the line, my coordinate, back to old algebra, 7th grade, x comma y plots a point. That point right here, x comma y, we can now use trigonometry to find that location of over x up y. in this case, this is a very special case of 45 degrees. They happen to be the same. Square root 2 over 2. So let's keep moving on. How many other triangles are on the unit circle like this? So how many other triangles can we do this for? Well, it's to answer the question, the answer is 3 more. 4 total. So one more would be coming straight out here, because then we can drop that down and we get 45. 45, 45, 90. So up here, the coordinates. Now this case, we're negative in the x direction, so that's negative square root 2, comma, positive in the y direction. Okay, similar triangle, just we have negative values. We also have another one coming straight across here. This coordinate is negative in the x, negative in the y. And our last triangle that we can do that to and get a 90-degree angle and 45 degrees. That's a positive in the x. Careful noting that we've gone to the right, so that's positive, but we've also gone down to the negative y values. All right, now last question. It says, using the triangle above, now find the following. So sine of 45 degrees. Okay, well that's right here. Sine, we already determined that. Sine of 45 degrees was the square root of 2 over 2. Cosine was also square root 2 over 2. Sine of pi over 4. If we haven't figured this out, pi over 4 is equivalent to 45 degrees, so that's, I don't know why we're doing this, but I'm going to fill everything out completely. So sine and cosine, remember those are the same because those are the x and the y. But let's look at tangent. What is tangent of 45 degrees? Well, the tangent, remember that's opposite, so y over x. So tangent of y over x is tangent of square root 2 over 2 divided by square root 2 over 2. So tangent of 45 degrees is 1. Or tangent pi over 4. There you go. That's our next set of notes. I'm going to keep rolling another video for equilateral triangles and a few other things, but I'll stop here for now.